Hi everyone. So in that video we are going to learn the next topic, which is a stack pointer. It's a very important topic in 8085 microprocessor. Basically it's a 16-bit register and it's hold the 16-bit address value. In our previous video we have already discussed the accumulator, 6 general purpose register, and another was program counter, and there was one accumulator. So three part. So in this tutorial we are going to talk about the stack pointer. So let's discuss this topic first. Stack pointer. So this is stack pointer. So it's a 16-bit register. That means it hold 16-bit address, 16-bit memory address. There is a two term here. One is a stack, another is a stack pointer. So let me first define the stack, then we will come to our next topic, which is a stack pointer. So what is stack? Basically stack is a memory location. Stack is a location in read write memory. Stack is a group of memory location. Group of memory location in read write memory. Second thing, this temporary storage holds the binary this temporary storage holds, or you may say store, the binary information during the execution of a program. During the execution of a program. That means this stack or this memory location hold the binary data during the execution of a program in temporary basis. It is not the permanent storage location. Third point, it's so important, when the microprocessor will store some data temporarily basis into the stack memory location, then how does it store it? How does it store those data into the stack memory location? It follow, basically this stack follow the LIFO principle. So this is the way basically the microprocessor read or write the data into the stack memory location. What does it mean, LIFO? Last in, first out. That means that the data which has been written last will be retrieved or will be read first. The data which has been written last will be read first. or you may say the vice versa also true for this condition. The data which has been written first will be retrieved last or will be read last. So this is basically the LIFO principle. When we will do the stack operation of, when we will see the operation of stack pointer, so at that moment we will perform this read write operation by taking an example. So at that moment we will see this principle, LIFO principle. And the fourth and most important, which is this stack, or you may say the stack is shared by microprocessor and programmer. That means both can operate with stack memory location. So both of them can operate this stack memory location. So these were some features according to the stack. Let's draw a diagram, a picture of those stack memory location that would clear your idea more vividly. As you can see here, this is a microprocessor. I have depicted some important part here. One is the stack pointer, which is a 16-bit register which hold the 16-bit address, and this is a program counter which is also the 16-bit register which also do the same thing. It also holds the 16-bit address, and there are the four general purpose register that you can see, D, E and HL. Now if you will come to here, then you will find that this is the main memory that I have drawn here over there, and this is a stack memory which is a part of main memory. By this black dotted line, I have segregated the part of stack memory from the main memory. That means stack memory belongs to the main memory that you can say. Another, let's comes to here, then you will find that these are the different location. These all are the different location which able to store 8-bit data at a time, and so each and every location has its own address value. That you can see 9005 is the address, and the data which has been stored into that address is XX, which is an 8-bit data. So another is a 9004. All are the different type of address for this different type of memory location. So now let's comes to the stack pointer. So let's define the stack pointer. Basically it's a 16-bit register. So the register which point the stack memory address is called the stack pointer. The register which points the stack memory address is called stack pointer. Another important thing about the stack pointer, this is a stack pointer. Stack pointer always point the highest, the top stack memory address. Stack pointer memory address. So this is basically the stack pointer which point the stack memory address and always point the top stack memory address. Now see over here, this is the top stack memory address. Here the top stack memory address is 9004. Why? Because 9005 and the up and the lower address location also filled by this particular 8-bit data. That you can see 9005, this address is filled by 9005. This address is filled by this 8-bit data that you can see over here, and then the 9004, from the 9004 there this stack is an empty one, so it will always point the top address location, which is a 9004 is a top address location, the highest address value here. So now it will start to point 9004 here. Now by this stack pointer we can operate two operation. We can perform two operation. One is a write, one is a read. Write or read. So let's perform the write operation first. So if you want to perform the write operation, let's assume something first. So let's assume that the HL register pair, this two, the HL register pair has been holding a particular address for a long time. Let's take the address which is 4240. So this address has been holding by the HS register pair for a long time, 4240. So in that address, this is the higher byte of the address, and in this address this is a lower byte of the address. Can we say that thing? Higher byte and the lower byte. And also when we want to perform a write operation into the stack memory, so always higher byte of the address will go to the highest memory location, which is 9004 here. That means higher byte is 42 and highest memory location here is a 9004. Then 42 will go to 9004. At that very moment, stack pointer will decrement its memory address value by 1. It will decrement its memory address value by 1. That means -1, and then it will start to indicate this address memory or this memory location. It will start to indicate 9003 memory location, and the lower value which is rest here, which is 20. This is lower value that you can see over here. So this lower value will go to this 9002. So in that way stack will perform the write operation. After that operation, then it will again decrement its address value by 9002 and will start to perform the highest or the top address of the stack memory that you can see 9002 is here. Now if you want to the read operation, that means write operation will be performed by decrement its address value -1, by decrements the stack pointer address value by -1, and read operation it's the opposite one. If you want to perform the read operation, that means let's take that 9002 also holding a supposed data which is y. So then stack pointer will, at the time of read operation, what it will do? It will start to indicate, or it will start to point lowest address of the field memory location, which is a 9002, and the field, this address is a filled by this 8-bit data which is at YY. So then what will happen? Then first suppose 9002, and then the microprocessor will read the data from the stack memory location which is YY. Then it will increment its address value and then will go to 9003. That means there will be 9003. It will start to point now 9003 and will then read, microprocessor again read the data of this stack memory location of 9003 which is 20, 9003 20. Then again it will increment its address value 9004 and so on. It will going to perform the, in that way it will start to perform the read operation which is 42 here, then 42, at the last it will read the 42. So by that operation, read and write, by that operation, by this read write operation, read and write, by this read write operation, it is clear that this stack location is maintaining the law of is abide by the law of by the law of LIFO principle. By this read write operation, that means at the read it will stack pointer always increment its address value by +1. So by this read write operation, it is quite clear that it is apparently clear that this stack location is abide by the law of LIFO principle. Abide by the law of LIFO, last in first in out. That means you can see over here the data which has been written here first has been read or has been retrieved last here at the time of read operation, but write operation it was written here first. In the same way, the data which has been written last, which was YY in write operation, but in the case of read operation it was read first, that is YY. That means this will be the first one for read operation, second one, third one, but here will be the first one for write operation, second one, third one, write, and this is read. So these were basic features, or these were basic information about the stack pointer. Another important was that stack pointer, if we want to store a particular register value, suppose the H register value, into the stack memory location, will it possible? Is it not possible? It is not possible ever. Always if we wants to store any value to stack memory location, the value should be a HL register pair. The value should be the register pair value. Register, it allow the register pair value, not the single register value. That could be a data, that could be an address, but it will always allow the register pair value, content of the register pair, content of register pair allow, but it will not allow the content of single register. So these are the basic features about the stack pointer.